about what? Which part of electrochemistry topic did we conclude? Hmm? Okay, so good morning everyone once again, and hope you remember we were talking about the electrochemistry topic. Okay, there we were talking about the electrochemical cells, the cells in which there is interconversion of electrical energy into chemical energy and vice versa. Electrochemical cells are of two types. One is electrolytic cell, the other one is galvanic or voltaic cells. Electrolytic cells are those cells in which electrical energy generates chemical energy, whereas Galvanic or voltaic cells are those cells in which a spontaneous chemical reaction gives electrical energy. ఇప్పటికి ఆఫ్టర్ 4 క్లాసెస్ మీకు అందరికీ అర్థమైపోయి ఉంటుంది ఏ టాపిక్ గురించి మాట్లాడుతున్నాము, ఎలక్ట్రోకెమికల్ సెల్స్ గురించి మాట్లాడుతున్నాం. ఓకే, ఎలక్ట్రోకెమికల్ సెల్స్ అంటే ఏంటి? ఇవి ఆపరేటర్స్ ఇన్ విచ్ దేంట్లో అయితే ఎలక్ట్రికల్ ఎనర్జీ అండ్ కెమికల్ ఎనర్జీ మ్యూచువల్ గా ఇంటర్ కన్వర్షన్ అవుతుంది. ఓకే, ఎలక్ట్రోకెమికల్ సెల్స్ 2 టైప్స్. ఎలక్ట్రోలైటిక్ సెల్స్ ఎక్కడైతే ఎలక్ట్రికల్ ఎనర్జీ కెమికల్ ఎనర్జీలో కన్వర్ట్ అవుతుంది. అలా కాకుండా galvanic or voltaic cells లో spontaneous chemical reaction electrical energy ఇస్తుంది. Okay, that's the overall concept. Okay, but what you need to remember here is that in all these cells there is a redox reaction taking place. Now, roll number 90. Good morning.
Good morning, ma'am.
Yeah. Boy, tell me what it means by a redox reaction.
Redox reaction.
The question is for everyone. Okay, what are redox reactions?
In which both reaction and oxidation takes place.
Yeah, okay.
In which both oxidation and reduction takes place.
Simultaneously. Then, okay.
Yes, ma'am.
Roll number 90.
Ma'am.
What it means by oxidation?
Electrons gaining, ma'am.
Loss of electrons or gain of electrons?
Gain of electrons, ma'am.
Did you write notes? I told you you should keep your notes near to you always. It's important. The dot points, what all I gave to you, are the most important concepts which you need to memorize time and again all throughout your session. Okay, Chapu, oxidation means loss of electrons or gain of electrons?
Gain of electrons, ma'am.
No.
Loss of electrons.
Loss of electrons is oxidation. What is reduction? Chapu, what is reduction?
Gaining of electrons, ma'am.
Gaining of electrons. So in a redox titration, there is mutual loss and gain of electrons between the reagents or species involved. Correct? Okay. Now, good. Now, roll number 100.
Yes, ma'am.
Good morning.
Good morning.
Now tell me the electrode at which oxidation takes place is called. The electrode at which oxidation takes place is called
Anode.
anode. Good. The electrode at which reduction takes place is called
Cathode.
cathode. In which cell? Electrolytic cell or galvanic or voltaic cell?
When electrolytic cell, anode positive. Cathode is negative.
Anode is positive. Cathode is
Negative. Galvanic cell, anode is negative, cathode is positive.
నేను అడిగిన క్వశ్చన్ ఏంటి? యానోడ్ దగ్గర ఆక్సిడేషన్ అవుతుందని చెప్పావు, క్యాథోడ్ దగ్గర రిడక్షన్ అవుతుందని చెప్పావు. కరెక్ట్ ఆన్సర్. ఏ సెల్లో? ఎలక్ట్రోలైటిక్ సెల్ లోనా గాల్వానిక్ ఆర్ వోల్టాయిక్ సెల్ లోనా అని అడిగా క్వశ్చన్.
Electrolytic cell.
మరి గాల్వానిక్ అండ్ వోల్టాయిక్ సెల్ లో ఏమవుతుంది? అక్కడ కూడా ఇదే అవుతుంది.
Yes.
అర్థమైందా?
Okay.
So it's for everyone. What you need to realize is that the oxidation electrode is always anode, the reduction electrode is always cathode, no matter whether it is electrolytic cell or galvanic or voltaic cells. That's the main idea, which should just enter into your head with a lot of confidence. And as your friend told correctly, the sign of anode is positive and cathode is negative in electrolytic cells, and in galvanic or voltaic cells, the anode is negatively charged and cathode is positively charged. Now, the whole discussion in this chapter revolves around the galvanic or voltaic cells, the cells in which a spontaneous chemical reaction gives electrical energy. Okay, so point number 21. ఎన్నో పాయింట్ చెప్పండి?
22, ma'am.
22. Right. The heading: galvanic or voltaic cells. Galvanic.
Ma'am, 21 point only, ma'am.
That is
Heading
21,
galvanic.
ma'am.
21 only.
అమ్మా,
That is
నేను
21,
చెప్పానా? ఇవి నోట్స్ చెప్పానా నేను ఆల్రెడీ? నోట్స్ కాదు, ఈ కీ పాయింట్స్
You
చెప్పానా?
just said definition, ma'am.
Only first point, ma'am.
Only definition.
నేను మొన్న డెఫినేషన్ చెప్పానా, వాట్ ఇట్ మీన్స్ బై galvanic or voltaic cell అని?
Yes, ma'am.
Yes, ma'am.
Okay, then we'll move. Okay, so I'm talking about what are called the galvanic or voltaic cells. Okay, voltaic cells. Okay, the cells in which chemical energy gets converted to electrical energy. And here we were discussing, see, there are various spontaneous chemical reactions. The spontaneous chemical reaction is also rusting of iron. Can that reaction be used for this purpose? No, absolutely not. Okay, so how to construct such cells? So what exactly might be happening? Okay, why the name is first is the major work is done by a scientist called as Volta. Till date, the cells are always called as Volta cells only. Okay, but they are improved by an Italian scientist called as Galvani, so galvanic cells. Okay, so they were building such systems which could generate electrical energy from a spontaneous chemical reaction. Is it not a common experience for us that there are certain reactions in which we have to supply a lot of energy to bring about the chemical reaction, but there are certain reactions which just take place spontaneously? Did you observe any time if you put soda in water or surf in water, can you feel the heat? Is it common thing?
Yes, ma'am.
Yes. Okay, why? The reactions are exothermic. Why the reactions are exothermic? Because the products are having less energy than the reactants. Fine, but how to construct a cell? No, by the way, roll number 110, good morning, you're there?
Good morning, ma'am.
Yeah, tell me what it means by a cell.
Ma'am?
Cell ante enna?
Electricity produces, sir.
అది సరే, ఎలక్ట్రోలైటిక్ సెల్ అంటున్నాను, ప్రొడ్యూస్ చేయకపోయినా సెల్ అంటే ఏమని చెప్పాను? whenever you're uttering that word cell, what it means?
Chemical reactions takes place.
Can anyone in the class answer me this question?
Combination of anode and
Combination of
cathode.
anode and cathode.
Exactly. అర్థమైందా నాన్న? Okay, So a combination of an anode and a cathode is a cell. Okay. Now I have to construct a cell. Initially, the discussion is very simple. Now, how a chemical reaction is taking place? There is surf, there is water. If you combine the both, there is heat energy. It's a spontaneous reaction. But how to generate electricity? What nonsense all this is. Might be a layman's idea. What was happening was actually, for example, a small thing they would do. And to start my discussion, there's a beaker containing dilute sulfuric acid, for example. And it was just like a storing of chemicals in various containers. Okay. And in that sulfuric acid bath, they dipped two rods. One was copper rod, the other was zinc rod. Okay. What they realized? They realized that copper was not suffering any degradation, but zinc was undergoing chemical degradation. What was happening to the zinc rod? Its size was getting shrunk. What they understood was that there's no problem dipping copper in sulfuric acid, whereas zinc undergoes a spontaneous chemical reaction much quickly. So, what they found? It was also giving good amount of heat energy. It is of what use if I have heat energy? Okay, there's a spontaneous chemical reaction and there is heat energy that is being liberated. But I don't want any heat energy. I want electrical energy. Now, how to construct such a system where I can get a net electrical energy from a chemical reaction? How to proceed actually was a very, very tough question. Obviously, what to do? Okay. So what they did, they understood that there should be one anode where there is oxidation reaction taking place. And they understood that there should be one cathode where reduction reaction has to take place. And they wanted to connect both anode and cathode. For example, ammeter, to know the direction of flow of current. Okay, so there should be two chemical reactions taking place. At one point, there should be a system which can lose electrons, and at the other end, there should be a system which should gain electrons. Because one is giving electrons, the other is taking electrons, it will be a redox reaction. And this redox reaction should be spontaneous. Very good. Understood. But it is not that very simple. Why? It is not just flow of electrons from one end to the other. Okay. How to create this potential gradient? ఒక కాపర్ రాడ్ ఒక జింక్ రాడ్ పక్క పక్కన పెడితే ఎలక్ట్రాన్స్ ఏం ఫ్లో అవ్వవు కదా, అంతే కదా. సో ఓకే, తెలుసు జింక్ తొందరగా ఎలక్ట్రాన్స్ లూజ్ అవుతుంది కాపర్ కన్నా అని తెలుసు, కానీ రెండు పక్కన పెడితే అవి రెండు ఎలక్ట్రాన్స్ లూజ్ అవుతాయా? అవ్వవు. అసలు ఈ సిస్టమ్ ఎలా క్రియేట్ చేయాలి అంటే, then they chose what they came to. Let us, and I am concluding quickly for time saving. What they thought, let us not discuss. So they created an anode by dipping zinc rod in zinc sulfate solution. Why? I'll tell you. And I'll ask you also, about your logical skills. Okay. Then they dipped one copper rod in copper sulfate solution, and they found zinc is one metal which will lose electrons, and copper is one metal will quickly accept electrons, which can quickly accept electrons. They have connected with the help of an ammeter or voltmeter for the flow of electrons with the help of wires, and internally they connected both the beakers with the help of
Salt bridge.
salt bridge. And salt bridge is, when you come to the college, you'll see it has agar-agar gel containing inert chemicals like KCl, KNO3, ammonium chloride, ammonium sulfate, like that. Okay, I'll explain in detail. Okay, they made this arrangement. So what you are seeing in front of you is called as a Daniell cell. Okay, actually you'll be surprised. What made them to create this Daniell cell was that after this, they went ahead into another experiment in which they dipped zinc rod in copper sulfate solution and copper rod in zinc sulfate solution. This is step 1. The step 2 was the next one. Okay, so they have done alternately. In which beaker you are expecting a reaction to take place? ఏ బీకర్ లో మీరు ఎక్స్పెక్ట్ చేస్తున్నారు ఒక రియాక్షన్ అవ్వచ్చు అని? జింక్ రాడ్ డిప్డ్ ఇన్ జింక్ సల్ఫేట్ కాపర్ సల్ఫేట్ సొల్యూషన్, కాపర్ రాడ్ డిప్డ్ ఇన్ జింక్ సల్ఫేట్ సొల్యూషన్.
జింక్ రాడ్ ఇన్ కాపర్ సల్ఫేట్ సొల్యూషన్.
జింక్ రాడ్ ఇన్ కాపర్ సల్ఫేట్. ఎందుకు? వై దట్
కెన్
గెస్?
రీప్లేస్ కాపర్.
Hello, the rest batch in the team. You are understanding what I'm saying? I've told you the construction of a Daniell cell. Now, how the Daniell cell was constructed is on these lines. It's like this is the program, this is the algorithm you're writing. There was a chemical reaction happening in the beaker containing zinc rod dipped in copper sulfate solution, whereas the other did not suffer any degradation. So they found that this beaker in which copper sulfate solution and zinc rod were present, zinc was losing its weight, and they found the copper to be deposited at the bottom when the system was left like that for long. Okay, so this is a spontaneous reaction, and here the reaction is non-spontaneous. Okay, so they understood that this reaction in which the zinc rod is dipped in copper sulfate solution is generating heat energy. So they felt this is a spontaneous reaction, and this reaction can be brought into utility for the production of electrical energy. After understanding that, how to make this reaction happen productively? What they were finding, that zinc rod was undergoing oxidation, okay, and that zinc rod had zinc with oxidation state 0. It was undergoing oxidation, and there is loss of electrons forming Zn plus 2 plus 2 electrons. Okay. In the solution, copper sulfate is there, and copper sulfate would contain these two ions, Cu2 plus ions and SO4 2 minus ions. These Cu2 plus ions were accepting electrons lost by the zinc to get deposited as copper metal in the bottom as PPT. And the reaction was spontaneous. Okay. And zinc was undergoing weight loss because it was entering the solution as Zn plus 2. And the solution was electrically neutral because of zinc sulfate that is being formed during the process. Okay, very good. A spontaneous chemical reaction is happening and there is liberation of heat energy during the process. But I want to create an electrochemical cell or a galvanic or voltoic cell from this chemical reaction. How to do it? They understood that there is always a difference in energy between zinc and Zn plus 2. Am I right or wrong? You understand? Roll number 84. Good morning. Roll number 83.
Good morning, ma'am.
Huh? Roll number 83 is present.
Yes, ma'am. Good morning, ma'am.
Yeah, good. You joined late.
Mic was not working, ma'am. Yes.
Okay. Now, I would ask you a question.
Yes,
What's
ma'am.
the oxidation of zinc in zinc rod?
Equation, ma'am.
I am asking you a question. Just listen to me. What is the oxidation state of zinc in zinc rod?
2.
కాదు, సరిగ్గా ఆలోచించి చెప్పు. నీకు కాపర్ వైర్ ఇచ్చాను. ఆ కాపర్ వైర్ లో కాపర్ ఆక్సిడేషన్ స్టేట్ ఏంటి అని అడుగుతున్నా. ప్యూర్ మెటల్స్ లో ఆక్సిడేషన్ స్టేట్ ఆఫ్ మెటల్ ఏంటి అని అడిగా. Anyone in the class, can you answer this question?
Zero, ma'am.
Zero.
Zero, madam. Zero, madam.
Zero. Okay, Nama?
Yes, ma'am.
Okay. Fine. I gave an aluminium rod to you. What is the oxidation state of aluminium in that aluminium rod? Girl. "83, are you there?"
Yes, ma'am. Yes, ma'am.
ఏం క్వశ్చన్ అడిగాను అర్థమైందా? అల్యూమినియం
Oxidation
రాడ్ ఇచ్చాను ఇప్పుడు కాపర్ బదులు. సో
Yes, ma'am.
ఆక్సిడేషన్ స్టేట్ ఆఫ్ అల్యూమినియం, ప్యూర్ అల్యూమినియం వైర్ ఏముంటుంది? అల్యూమినియం దాంట్లో ఆక్సిడేషన్ స్టేట్ ఎంత ఉంటుంది?
3.
0. కరెక్ట్.
Zero.
Keep confidence and
Yes,
answer
ma'am.
the question confidently. సరే,
Yes, ma'am.
అంటే what did you conclude? I've given you a copper wire, I gave you an iron wire, and I gave you an aluminium wire. In all these wires, what is the oxidation state of individual metal?
0.
0. Correct. Will all these metals have resistance for flow of electrons?
No, ma'am.
ఉంటుంది. ప్రతి మెటల్ కి ఎవ్రీ మెటల్ ఆఫర్స్ రెసిస్టెన్స్ ఫర్ ఫ్లో ఆఫ్ కరెంట్. ఎందుకు? ఎలక్ట్రాన్స్ కాబట్టి. మెటల్స్ లో ఎలక్ట్రాన్స్ ఉంది, నువ్వు బయట నుంచి ఎలక్ట్రాన్స్ పంపించావనుకో, లైక్ పోల్స్ అట్రాక్ట్ అవుతాయా, రిపెల్ అవుతాయా? రిపెల్ అవుతాయి, అవునా? సో
Yes, ma'am.
బయట నుంచి వచ్చే ఎలక్ట్రాన్ ఫ్లో ని ప్రతి మెటల్ అపోజ్ చేస్తుంది. అపోజ్ చేసే ఫోర్స్ నే ఆ రెసిస్టెన్స్ ఆఫ్ దట్ పర్టికులర్ ఎలిమెంట్ అని అంటాం. సరేనా?
Yes, ma'am.
Okay, I'll get back to my next point. Sare. Now there is zinc sulfate solution. Okay, there is zinc sulfate solution. What is the ox? And the formula is ZnSO4. Now, can you tell me what is the oxidation state of zinc in ZnSO4?
Plus 2.
Plus 2.
plus 2. Okay. Now roll number 74. Good morning.
Madam, good morning.
Now do you expect that Zn in 0 oxidation state and Zn in plus 2 oxidation state will have same energy or different energies? Enana,
Different energy, ma'am. I think.
what I was asking you, did you understand?
Yes, madam.
Does zinc metal and zinc ions have same energy or they are at different energies?
Different, madam.
Different.
Yes, madam.
Now can I use that for my generation of electrical energy?
Yes, madam.
Yes. Good. Okay.
Okay, ma'am.
Now I am explaining what it means by construction of electrochemical cells. Okay. So while I'm constructing an electrochemical cell, I need two different metals preferentially. Okay. And those two metals, just like iron, copper, and aluminum rods, are all having 0 oxidation states. If I place these metals in side by side, it's of no use. So the metals should be in contact with preferentially their own metal ions. Okay. So what they did, they understood that the zinc metal dipped in zinc sulfate solution also exhibits lot of potential difference, which can be used for generation of electricity. This is how I am constructing an electrochemical cell. So instead of dipping zinc in copper sulfate solution, they improvised the concept of making an electrochemical cell. What they found? They found that zinc is losing electrons and copper is gaining electrons. So zinc will act as anode and copper will act as cathode. They understood this from this initial experimentation. Now, the same concept, I want to make it into an electrochemical cell. Okay. So, how they constructed? ఒక జింక్ రాడ్ ని కాపర్ సల్ఫేట్ సొల్యూషన్ లో డిప్ చేస్తే వాళ్ళకి ఏం అర్థమైంది? ఒక స్పాంటేనియస్ కెమికల్ రియాక్షన్ అవుతుంది, జింక్ వెయిట్ లూజ్ అవుతుంది, కాపర్ డిపాజిట్ అవుతుంది కింద. ఇవన్నీ వాళ్ళకి అర్థమైంది. అప్పుడు అర్థమైనప్పుడు వాళ్ళకి క్లారిటీ వచ్చేసింది. ఎందుకు ఏది యానోడ్ ఏది క్యాథోడ్ అని అంటే ఎప్పుడు అలా అర్థమైంది? జింక్ యానోడ్ కిందనే ఉంటుంది, ఎందుకంటే అది ఎలక్ట్రాన్స్ లూజ్ అవుతుంది కాబట్టి. యానోడ్ ఈజ్ ఆక్సిడేషన్ ఎలక్ట్రోడ్. ఇంకోటి కూడా అర్థమైంది వాళ్ళకి, కాపర్ క్యాథోడ్ కింద యాక్ట్ చేస్తుంది అని. ఎందుకు? అది ఎలక్ట్రాన్స్ తీసుకుని ఇట్ ఈస్ గెటింగ్ డిపాజిటెడ్ యాజ్ కాపర్ మెటల్. అది రివర్స్ అనేది పాసిబిలిటీ అంటే అవ్వలేదు. ఎందుకు? వాళ్ళు ఒక బీకర్ లో డిప్ చేసి చూసారు కాపర్ రాడ్ ని జింక్ సల్ఫేట్ సొల్యూషన్ లో, నో కెమికల్ రియాక్షన్ హ్యాపెండ్. సో దాన్ని వదిలేసారు ఆ కాన్సెప్ట్ ని. సో ఈ ప్రాసెస్ లో there was generation of heat energy. Now they wanted to construct an electrochemical cell. దానికి వాళ్ళు ఏ ప్రిమైస్ తీసుకున్నారు? The premise which I have just been telling with you. So now this heat energy should be brought into a electrical energy. ఎలా చేయాలి అంటే they understood there is a potential difference between zinc and Zn plus 2 ions. Okay. And they also found that there is a potential difference between copper and copper sulfate ions. Okay. That is CuSO4. Okay. Because both the systems are different. Here you have straight away Zn into Zn plus 2. Here copper and copper 2 plus. Okay. And the tendency of zinc was to lose electrons when it was combining with copper. So they made electric wire for flow of electrons. What they found was that zinc, particularly in the form of ionic states, when it is in contact with copper, is showing a tendency to lose electrons. And the lost electrons are just taken away by the copper ions that are present in the solution. So, zinc rod is showing the tendency to lose electrons, and copper ions present in copper sulfate has a tendency to gain electrons. A redox reaction possible. But this redox reaction, if connected directly, is giving heat energy. I wanted to make it into electrical energy. Why? How the power will flow from anode to cathode against a potential difference. Now, how to create a potential difference? The main reaction is between these two. Okay, so have to create one anode and cathode. How to create an anode? This is how they created an anode, by dipping zinc rod in zinc sulfate solution. And they dipped copper in copper sulfate solution. But the main reaction is between Zn and Cu2 plus ions. That's a spontaneous reaction. Okay, so what was happening? Here, the zinc rod was losing electrons, and the electrons are being transferred with the help of wires into this system. Here, the copper is just acting as an electrode, and it is slowly transferring electrons into the copper sulfate solution, where the sulfate copper ions present in copper sulfate are gaining electrons to get deposited as copper back on the copper rod. But after some time, what you realize is that there is excess of zinc ions here and excess of sulfate ions here. To maintain electrical neutrality, I'll use a salt bridge for the purpose. So what is the role of salt bridge? To keep the electrical neutrality between the two solutions. And what you are seeing here is nothing but a Daniell cell. What I was trying to explain is a small concept, but with depth of understanding. Understand this, you can quickly answer the rest questions easily. Okay, so that's the construction of electrochemical cells. Okay, now would you take 2 or 3 points there? Construction of electrochemical cells. First point, a spontaneous redox reaction. A spontaneous redox reaction gives electrical energy. Gives electrical energy. Okay, first point. Second point, anode is oxidative electrode. Anode is oxidative electrode. And cathode is reductive electrode. Cathode is reductive electrode. Anode is oxidative electrode. Cathode is reductive electrode. Cathode is reductive electrode. Next point. Anode and cathode are constructed, anode and cathode are constructed by dipping a metal in its own metal ion solution. Okay, you understood? Anode and cathode are constructed by taking a metal rod dipped in its own metal ion solution. Example, in Daniel cell, anode is zinc rod dipped in zinc sulfate solution. In Daniel cell, anode is zinc rod dipped in zinc sulfate solution. Cathode is copper rod dipped in copper sulfate solution. Copper rod dipped in copper sulfate solution. Okay. Next point. The electrodes are externally connected. The electrodes are externally connected with wires for the flow of electrons. The electrodes are externally connected with the wires for the flow of electrons. Next point. Within the construction of electrochemical cell, you can write it as A, B, C, and D and write these points. Okay. Now, electrodes are internally connected. Electrodes are internally connected with the help of a salt bridge. With the help of a salt bridge. Okay. Next point. The redox reaction is equal to cell reaction. Cell reaction is equal to redox reaction. The cell reaction is nothing but the redox reaction. Electrodes are called half cells. Electrodes are called half cells. Electrodes are called half cells. electrode reactions. Electrode reactions. Or electrode reactions are half cell reactions. Electrode reactions are half cell reactions. Okay. So in an electrochemical cell, the redox reaction is nothing but the cell reaction, and the electrodes, okay, that is anode and cathode, are called as half cells. How the electrodes are constructed in a galvanic or voltaic cells? By dipping a metal rod in its own metal ion. Okay. So whenever I am talking about an electrode, it means the metal rod dipped in its own metal ion solution. So the entire system is called as an electrode, and these electrodes are called half cells. Okay, and the reactions taking place at these half cells are called as half cell reactions. You understood? Okay. Now, roll number 120. Roll number 120. Good morning. Okay.
Absent.
Roll number, roll number 120 is present.
Absent.
Indama? Okay, no problem. So, roll number 85. 84 is absent, I think. Roll number 84 is absent.
Present, ma'am.
84. Good morning.
Ma'am.
Yeah, tell me. ఏం అర్థమైంది మీకు? ఈ ఎలక్ట్రోకెమికల్ సెల్స్ లో ఎలక్ట్రోడ్స్ ఎలా కన్స్ట్రక్ట్ చేస్తారు? బై డిప్పింగ్ ఏ మెటల్ రాడ్ ఇన్ ఇట్స్ ఓన్ మెటల్ అయాన్ సొల్యూషన్. ఎగ్జాంపుల్ ఒక డేనియల్ సెల్ చెప్పాను. దాంట్లో ఏం చెప్పానంటే యానోడ్ zinc rod
dipped on zinc sulfate solution.
whereas copper rod dipped in copper sulfate solution is the cathode. ఇప్పుడు ఎలక్ట్రోడ్ అంటే ఏంటి? యానోడ్ అండ్ క్యాథోడ్. సో దానిని ఎలక్ట్రోకెమికల్ సెల్స్ నేను ఏమంటాను? హాఫ్ సెల్స్ అంటాను. కరెక్ట్? What is anode? What chemical reaction takes place at anode? Anil.
Oxidation.
So what is oxidation half cell? Anil.
Loss of electrons, ma'am.
Clearly. ఏం అడుగుతున్నాను అర్థమైందా? In this Daniel cell, which is anode? Anil? In Daniel cell, which is anode?
Zinc, ma'am.
ఇప్పుడే చెప్పాను కదా. చెప్పు.
Zinc is anode, ma'am.
Zinc rod dipped in zinc sulfate solution is anode.
Anode. Yes, ma'am.
And the chemical reaction is called as?
Half cell reaction. Half cell reaction, ma'am.
Oxidation. So, the chemical reactions at electrodes are called as?
Yes, ma'am. Half cell reaction.
Half cell reactions. So, at anode, oxidation is taking place. So, what is the reaction at zinc in zinc sulfate solution called?
Ma'am?
Oxidation half cell reaction. You understand?
Yeah, yes, ma'am.
So, at anode, where zinc is dipped in zinc sulfate solution, it is oxidation half cell reaction. At cathode?
Reduction half cell reaction.
Okay, reduction half cell reaction. And the net reaction is called as? And the net reaction is called as?
Redox half cell reaction.
Yes. Redox reaction. It is nothing but the cell reaction of the Daniell cell. Okay, good. Now, what will be the cell reaction? What will be the cell reaction? Roll number 86. Good morning. Roll number 86 is absent. 87.
Yes, ma'am.
Good morning.
Good morning.
Yeah, tell me. What is the cell reaction? What is the redox reaction that is taking place? Can you guess? What is redox reaction?
Oxidation and reduction taking place simultaneously.
Now, can you guess the cell reaction for this Daniell cell?
Zinc plus copper. Zinc plus copper plus 2 reacts gives rise to Zn plus 2 plus copper.
Lovely. Okay. Is she correct? Anyone in the class?
Yes, ma'am.
Is she correct? Yes or
Yes,
no?
ma'am.
Yes. How many say it as no? Raise your hand. So the discussion completes. ఏం చెప్పాను? యానోడ్ దగ్గర ఆక్సిడేషన్ అవుతుంది, క్యాథోడ్ దగ్గర రిడక్షన్ అవుతుంది. యానోడ్ ఆక్సిడేషన్ హాఫ్ సెల్, క్యాథోడ్ రిడక్షన్ హాఫ్ సెల్. అండ్ రియాక్షన్ ఏమంటారు? హాఫ్ సెల్ రియాక్షన్. అంటే యానోడ్ ఆక్సిడేషన్ హాఫ్ సెల్ రియాక్షన్ అండ్ క్యాథోడ్ రిడక్షన్ హాఫ్ సెల్ రియాక్షన్. ఏమవుతుంది? Zn. The overall reaction is ఏమవుతుంది? Zinc rod is losing electrons to get converted to Zn plus 2 plus 2 electrons. Okay. Whereas the copper is not just doing anything. First, it is allowing electrons, and the electrons that have entered the cell actually are taken up by Cu2 plus ions. If Cu2 plus ions ఎక్కడ ఉన్నాయి? Copper sulfate లో ఉన్నాయి. Getting deposited as copper. Okay. So what is overall reaction? Zn plus Cu2 plus gives Zn plus 2 plus copper. That is the overall cell reaction. Okay. So what you'll write? The cell reaction for Daniell cell is equal to you should always write like this. Zn gives Zn plus 2 plus 2 electrons. Oxidation. Next we will write Cu2 plus 2 electrons gives Cu. The overall reaction is Zn plus Cu2 plus gives Zn plus 2 plus copper. That is the overall reaction. Okay. Okay. Next. Now, I want to make you write the cell reactions for certain electrochemical cells. Okay. So, meantime, I shall take attendance. What's the time? It's 12:10. So, it's almost, it should conclude now. Write the cell reactions for the following electrochemical cells. For the following electrochemical cells. Zinc and silver, zinc and silver, nickel and copper, nickel and copper, iron and zinc, zinc and iron, zinc and iron. Will you? I should first tell me which will act as anode and which will act as cathode. Tell me, are you writing? Hello, good morning. 61.
Yes, ma'am.
Please do not leave. You should tell me the answer and leave. I'll take the attendance quickly. Answer this and you can leave. Now I've told
Okay.
you. What are the three things I've told you? Nickel combined with silver, zinc combined with silver, and nickel combined with copper. Copper ichana.
Yes, ma'am.
Nickel combined with copper. Zinc combined with silver. Inkoti. Zinc combined with iron. ఇది three combinations. Cell reactions trial మీరు. Siddharth, roll number 16. Good morning. You should give me the answer. Okay. 62.
Yes, ma'am.
63.
Ma'am, 64, ma'am.
64.
Present, ma'am.
65.
Present, ma'am.
66. 67.